Welcome to qnawire.
All right. So in this problem, we have set up capital Q over here, and we have two other Q's here and there. And then we know the distance between the capital Q and the Q1. So this is 3 centimeters. This is 3 centimeters as well. And the distance between Q1 and Q2 is 4.5 centimeters. And we know the capital Q is negative 1.75 microcoulombs. So the mass of capital Q is 5 grams. And initially, we know that the acceleration of the capital Q is 324 meters per second squared. So we want to find out the charge of Q1, Q2. And another condition is this acceleration is pointing up. Okay. So by using these conditions, we can see that the Q1, Q2, they have to, their charge have the same magnitude. The reason is if Q1 and Q2 have different charges, like different magnitude, then the force will be something like this. They do not have the same magnitude, right? Otherwise, in this case, there will be a net residue on the x direction. So the acceleration will not be pointing to the y direction. So based on this reason, we can just say that the Q1 equal to Q2, equal to, and another condition is since Q1 and since the force is pointing up, so by using the force division, it has to be like this, right? So because Q is negative charge, so Q1 has to be positive and Q2 has to be negative. So we just say that this equal to Q, okay? So the net force on the capital Q, we can have the expression F equal 1.4 pi epsilon naught times Q times capital Q, which is negative 1.75 microcoulombs, divided by the distance, which is 3 centimeters. So this is the magnitude of the force exerted by Q1. And we just need to find out the y component. So times the y component, we just need to times the factor 2.225 divided by 3. So this factor comes from suppose this is theta, comes from cosine theta. So cosine theta, if you utilize this triangle, you'll see that the cosine theta equal 2.25 over 3, okay? And so this is the force exerted by Q1, and the force exerted by Q2, they have the same expression actually. So we just times 2 and minus mg, which is the gravity, divided by m. This will give us the acceleration. So we know that this is equal to 324 meters per second squared. Okay. So in this expression, you can see that the only unknown variable is this q, the small q. We already know the mass and we know the g. So we just plug in all the values and solve for q. You can actually find that q finally equal to 6.36 times 10 to the negative 8th coulombs. So in that case, Q1 is positive. It's 6.36 times 10 to the negative 8 coulombs, and Q2 is the opposite one. Okay.